Hey, Miss Belmore, do you want to play tennis?
It's 32 degrees outside.
It's beautiful out. I've got my lucky tennis hat. Let's play tennis.
Wait a second. I have one too.
All right, we're
It's
there.
still 32 degrees though.
Yep. Well, we can play. What's the difference between how cold it is?
Because when it's really cold, the tennis balls don't bounce so high, and I am older than you and not as fast, and it puts me at a disadvantage.
You saying temperature affects how high a tennis ball bounces?
Yes.
Let me see.
Okay.
Just the one, right? All right, we gotta go get the tennis ball 3 hours later.
If we want it to be an experiment that is fair, a controlled experiment, we need to have only one variable. So we have all these tennis balls with different brands, different size.
Different
oh my
ages.
gosh, what is that? That's different ages. We need to choose same brand, same age. These are both brand new, Ms. Walbar?
Yeah.
And the only difference, the only variable should be the thing we're testing.
This one's room temperature, and this one's cold. So cold. All that remains is to test the tennis balls. The room temperature tennis ball is on the left, and the cold tennis ball is on the right. What do you notice happened here? In science, it's always good to do repeated trials, so let's see what happens the next time. The warm tennis ball is on the left, the cold tennis ball is on the right. What is the independent variable, the dependent variable, and the constants? It's impressive. Even though the cold tennis ball started first, the warm tennis ball caught up and beat it.
At a disadvantage.
You saying temperature affects how high a tennis ball bounces?
Yes.
Let me see.
What conclusions can you make from this experiment?